Developed for professional broadcast and production applications, the M2 format uses high-density recording to achieve superb picture quality, employing 1/2-inch cassette tapes. This convenient format provides the added advantage of compact, lightweight equipment capable of extended recording time. M2 equipment is suitable for all phases of production, from acquisition to editing to broadcasting. It's the tool professionals need to maintain high quality while cutting equipment, operation, and maintenance expenses. M2 users know that the M2 format is capable of producing high-quality video footage and spectacular graphic and digital effects. But getting the best results requires proper preventive maintenance of the equipment to ensure peak performance. Panasonic, in cooperation with the M2 Users Association of America, has produced this videotape to help you properly clean and maintain your equipment in order to get the maximum performance quality for which the M2 format is famous. This presentation demonstrates cleaning and maintenance techniques for both field and studio M2 units. The tools used in cleaning include screwdrivers, pliers, inspection mirror, and cleaning sticks. You will also need isopropyl alcohol, linen Tex wipes, and compressed air. Upper drum assembly. To facilitate this demonstration, we've removed the chassis from an M2 studio machine. Let's first look at some key functional elements. The video heads are mounted to the upper drum assembly shown here. First is Channel 1 Y&C. Then the flying erase head for Channel 2, Channel 2 Y&C, and the Channel 1 flying erase head. Also located on the upper drum are small grooves called air bearings. These grooves create a pocket of air that prevents the tape from sticking to the upper drum. These grooves must be kept clean. Clogged air bearings can cause stiction, or tape sticking to the drum due to dirt or cleaning fluid residue. One method of head cleaning is to use a chamois stick dipped in isopropyl alcohol, applied evenly to the upper drum. Hold the stick stationary, applying light, even pressure while rotating the drum. Do not move the stick up and down because this will damage the head. When the head appears, move the upper drum assembly gently back and forth to relieve any head clog. Again, it's important to remember to never use an up and down motion on the head, as this will cause damage. An alternate method of cleaning is to use a linen Tex wipe wrapped around a finger and dipped in alcohol. Hold the wipe gently and evenly against the head and rotate the drum. Again, do not move the wipe up and down. It could damage a head. When a head appears, rotate the drum gently back and forth. Now, dip a toothpick into alcohol and clean the air bearings. Hold the toothpick stationary while rotating the drum. Also make sure you clean the lower tape guide shown here. Repeat the entire procedure using GenSolve 2000. AC headstack. The AC stack for the M2 2-digit series studio deck is shown here. This is a 2-pole head with the full erase head on the left and the audio head or RP head on the right. On the audio head, from top to bottom, are Channel 2, Channel 1, Control Track, and finally Timecode. This is a 3-pole type AC stack for the AU520. It's comprised of a full erase head on the left, RP heads in the middle, and confidence heads on the right. This long one is an MR head, which is used to read Control Track in slow speed. The goal is to clean up under the plate to clean Channel 2, Channel 1, Control, and Timecode. Two important notes. First, when cleaning the audio head, it's difficult to get the cleaning tool under this top plate. but it's important to clean channel 2, which is located here. Dirt on channel 2 can cause as much as 3 dBs reduction in level. This is why it's important that before adjusting the M2 unit to correct level loss, try to get in and thoroughly clean channel 2. If cleaning doesn't solve the problem, check the tape for edge damage, which can happen because channel 2 is towards the outside of the tape. Secondly, it's important to note that there is grease along the mechanical path here. In this particular case, there is excess grease in here that needs to be carefully cleaned away. If this grease is picked up and deposited in these heads, it could cause loss of control track and timecode clogging. Another problem is that when the grease gets deposited on the AC head, it could be picked up by the tape as it moves through the unit. The tape can then become a carrier to spread the grease into other machines. To prevent facility contamination, it's important to always check to ensure cleaning tools are not spreading grease during your preventive maintenance program. Now let's go on to cleaning the AC heads. Cleaning the AC head can be complicated by the position of the pinch roller in front of the AC head as shown here, when the loading ring is in the unload position. To move the loading ring, push down on the loading ring gear, which allows you to move the pinch roller and guides away from the AC head. You now have access to the AC head for cleaning. The AC heads can be cleaned with a chamois cloth stick, or with the linen Tex wipe as shown here. The critical area to concentrate on is again under that plate where channel 2 is located. Again, remember to use a side-to-side motion. Up and down motion here must be avoided because this would transfer dirt from one head to another. Note that there are moving parts within the chassis that have grease on them, one being this guide right here. Exercise care to avoid transferring this grease. Cleaning sticks are recommended because they don't come into contact with the grease. When using Tex wipes, avoid contacting the grease, and if grease does get on the wipe, discard it to prevent the grease from getting on the head. Field cleaning the portable unit. To field clean the portable unit, first remove the small access plate. Clean the video heads holding the cleaning stick stationary while rotating the upper drum. In order to clean the AC stack, you'll first have to remove the pinch roller assembly, and there is an E-ring that has to be removed to allow this to occur. The E-ring is removed here. Then the pinch roller assembly is removed. Clean inside the AC stack with the cleaning stick. An alternative method is to clean the AC stack with the Tex wipe as before. On the inside of the AC stack, it's important to clean under the plate. Be careful not to pick up and transfer grease in this area. Replace the pinch roller, being careful that it doesn't get caught here and that it fits in the guide. Make sure that it moves up and down. Push the pinch roller down and install the E-ring, as shown here. Make sure it doesn't come off. More thorough cleaning can be effected in the shop by removing the cassette assembly plate and the outside cover with the screws shown here. The cassette assembly can be released with this small catch. Inside the unit are the upper drum, the AC stack, the erase head, the loading motor, which features an emergency eject, the tape guides, and the 3 reels here, here, and here. Tape path. It's important to understand the tape path to effectively perform preventive maintenance procedures. The tape leaves the cassette and comes to the P1 guide, which is an upper limit guide. The tape then moves to the P2 guide, also known as the entrance guide. This is also an upper limit guide. The tape then moves to P3, a free limit guide. After adjustment of the P2, it's important to remember to bring up the base of the P3 until it just touches the tape, and then back it off a quarter turn and tighten the cap. P4, an upper limit guide post, is the last guide that sets a limit before the tape enters the lower guide of the lower drum. Move P3 and P4 out of the way when adjusting the height of P2 to eliminate their influence on the tape. Look at the tape path between P4 and the lower limit. Check that there is no tape curl at P4, and no tape deformation at the entrance to the lower guide. Note that the lower drum is the lower reference. As the tape exits the lower drum, it goes to P5, the exit guide, another upper limit guide. Do not make adjustments to P5. It is set at the factory with an optical jig, but make sure that P5 is aligned to the lower drum. This is the upper limit here, and this is the lower limit. If the upper limit has been misadjusted, you can recognize it by the way the tape rides off the drum. If the post has been set too low, the tape will ride low here and cause curling. If the post has been set too high, it will cause the tape to ride high. If you think the tape is riding incorrectly, a qualified technician must either readjust P5 or optimize the exit portion of the RF envelope with the tilt adjustment shown here. The tape moves through the AC head to the P6 guide, which is very important on models that have automatic tracking. P6 becomes an entrance guide when the tape is reversed. If there is curling at the base of P6, that will cause the RF envelope to tear when you go in reverse or when you jog forward and reverse in automatic tracking. The tape then moves to P7, an upper limit guide, and then moves around the outside of the pinch roller over the inclined post to P8, which is a free limit guide. It then moves to P9, which is also a free limit guide. The tape then moves across to the P10 post, a lower limit guide, which is set upside down, shown here. The tape goes through an inclined post that ensures tape contact with the timer roller is correct. Next in line is P11, the take-up guide, which is a free limit guide. After leaving P11, the tape goes through P12, another free limit guide, and finally back into the cassette. Cleaning the pinch roller. If the assembly is in the fully loaded position, you'll find that the pinch roller is parallel to the capstan and the pinch solenoid is in contact with the pinch roller. Thus, the pinch roller is not accessible for cleaning. To make it accessible, first power down the unit. Push the load ring gear down to allow movement of the pinch roller around to the front for access. Then, using a Tex wipe dipped in a 50-50 solution of alcohol and water wrapped around your finger, clean up and down on the pinch roller while rotating it with your other hand. Do not use 100% alcohol because this would definitely disintegrate the rubber. Use a new section of Tex wipe and repeat the cleaning process. Afterwards, repeat the process using a fresh dry Tex wipe to remove any alcohol residue. Clean with the dry Tex wipe until there is no black residue shown on the Tex wipe. Cleaning the capstan. The capstan shaft is the prime mover of the M2 tape through the mechanism. This shaft moves the tape. Using alcohol on a Tex wipe, move your finger in an up and down motion while turning the capstan as shown here. A capstan that needs to be cleaned will leave a brown spot on the Tex wipe, indicating tape oxide that has been deposited as the tape traveled over the shaft. A dirty capstan will cause an increase in wow and flutter distortion of audio during recording. Cleaning the capstan can correct such degradation. Cleaning the posts. The posts guide the tape through the transport. In cleaning the posts, it may be necessary to first move the mechanism into the unload position so that the P1 and P2 posts are accessible for cleaning. To do that, push down on the load gear to allow you to move the load ring and bring the P11 or take-up arm and P2 or supply arm back to meet with the P1 post. In this alignment, they are easiest to clean. The various components of the post include the upper flange, the post shaft, and the lower limit. Using a dry Tex wipe and pushing down on the lower flange, clean the area between the lower flange and the shaft. Dry wipes only are used because of the precision bearings inside the shaft. Then, holding the shaft, pull it down to reveal the area above the shaft under the upper flange. Clean this area in the same manner. Finally, clean the shaft thoroughly with a dry Tex wipe to remove any fingerprints and residue. Cleaning the fixed posts. The fixed or inclined posts are located here on P10 and behind the pinch roller here. A Tex wipe can be used in this manner to clean each of these posts. Because these posts meet the surface of the tape along the sides shown here, it is important to check for tape wear. Run a fingernail or a toothpick over the post to check for ridges. If you detect ridges, the post should be replaced. The post near the pinch roller should be changed with each replacement of the upper drum, roughly 1500 hours. Earthing brush assembly. The earthing brush assembly is located here. This particular chassis comes from an AU65, a player recorder without automatic tracking. The purpose of the earthing brush is to dissipate any static charges that have been picked up by the upper drum assembly. There is also a brush assembly for models that do have automatic tracking, shown here. This particular upper drum assembly comes from an AU650. The controlling voltages for the AT heads come through this slip ring assembly and brushes. Section 10. Cleaning the earthing assembly. The earthing brush is located here, and the slip assembly is located here. The first step in cleaning the earthing assembly is removal of the earthing brush. Clean the contact area of the earthing brush on a pad moistened with alcohol. Rub it on the pad until dirt is removed. Next, clean the slip assembly located here. Using an alcohol-moistened Tex wipe on your finger, clean the top of the assembly while rotating the upper drum to remove any deposits, making sure it is clean and shiny. Now replace the slip assembly and earthing brush. While tightening the screw, hold the brush with your finger to make sure it is centered on the slip assembly. This is an upper brush assembly from an AU650, a unit that has automatic tracking heads. The slip ring assembly is in the front, and the brushes are on the side. Using a cleaning stick, clean inside each one of the slip rings while turning the assembly. To disassemble the brush assembly for cleaning, remove these two screws. And then remove the brush assembly. With an alcohol-moistened Tex wipe, clean the brushes by stroking outward, taking care not to bend the brushes. Note that the brushes consist of 5 strands together. During the cleaning process, check for wear along the edge, and check for worn grooves on the brushes. These grooves will cause white sparkles on recording or black dots on playback. This brush noise is sometimes mistaken for dropouts. After cleaning, make sure the brushes are straight. To reassemble, insert and tighten the 2 screws. Make sure there are no cross connections or shorts and that the brush is aligned with each slip ring in the assembly. Now the slip ring and brush unit must be adjusted. The adjustment of the slip ring and brush unit is controlled by the Allen key shown here. After the Allen key adjustment here, turn it until this rubber cuts an imaginary line through the slip ring assembly as shown in the maintenance procedure. Final disassembly and cleaning. Before proceeding, make sure the power is off. Remove the 2 screws on the right side of the carriage and the 2 screws on the left side. Pull the front panel away. You now have access to the top. Then remove the 4 screws on the top in the locations shown. Be sure to put the screws and parts in a container as you remove them. Remove the plate. If the cassette assembly is not fully up and out of the way, Move it by turning the loading motor one way or the other. There are 2 screws for the cassette assembly which need to be removed. As you can see, it's best to use a magnetized screwdriver with a long shaft. Now move the cassette assembly forward to gain access to the 2 back screws. Remove the back screws. The cassette assembly is now free to come out. Unplug the loading motor connector and place it on the side. Now you can move the cassette assembly up to the rear of the unit, up and back out. Take care not to pinch wires at the side of the unit. Pick the unit up, move it towards the back, lift it up, back it out, and up. Take care not to damage the record inhibit sensors. Now the cassette assembly and the mechanical chassis is free and clear. Let's talk about the brake and reel table. In the older M2 units, such as the AU650, the reel table is set with 2 brakes above. These brakes need to be cleaned. They are the brake for the supply side and the brake for the take-up side. In addition to cleaning the brakes, the pads, you also need to clean the sides. Clean the reel using a cleaning stick dipped in a mixture of alcohol and water while turning the reel. Then push the brake away and try to get some of the cleaning fluid inside the brake. Once the fluid is in the brake, engage the brake by turning it. Then use a wipe to remove the cleaning fluid. Clean the other brake in the same manner, cleaning down inside the brake. This is the cassette assembly. The sensors in here should be cleaned by blowing them with canned air. The sensors consist of the end of tape sensors, one which is located here, and the other which is located here. In addition, there are 2 cassette in detect switches, located here and here, as well as the small cassette in detect leaf switch here. To clean the front angle guide of the cassette assembly, wipe the front angle guide, paying special attention to the corners. While you have the unit disassembled, lubricate the worm gear, the idling gear, and within the tracks. Remove the cover, then take out the circuit boards. Clean the edge connectors with the GenSolve 2010. After the boards are all removed, protect the upper drum assembly and dust the gaps between the circuit boards with compressed air. Now replace the boards. Make sure all the edges are clean before they are replaced. Reconnect any of the connectors as you replace the boards. Replace the rear cover and tighten the screws. Now the cassette assembly can be replaced. The cassette assembly is loaded down, being careful not to pinch wires. Plug in the connector. Replace the 2 screws down in here and here. Move the cassette assembly out of the way to gain access to the other 2 screw holes by turning the loading motor. Replace the 2 screws in this hole and this hole. Tighten up all 4 screws. Now replace the top plate, making sure this wire is not pinched. Install the 4 screws in the top plate. Note that it is important to make sure that this cable does not get pinched in the gear when installing the front panel. Replace the front panel and install the screws. Only partially tighten the screws until all 4 have been installed. Finally, replace the top panel and tighten the screws. Emergency tape unloading procedures. Let's look at the emergency eject procedure for the portable units. For the AU400 and the AU500 series, the procedure is basically the same. Unscrew the emergency eject latch and lift the latch up. When this latch is lifted, it engages a roller onto the gear for the supply reel, which is down in here. An arrow on the latch shows the direction to turn the wheel after the latch is in the up position. The easiest way to turn the wheel is to insert a flat-tipped object such as a stick or a screwdriver and turn the wheel. Continue until the cassette pops up. Remove the tape. To get the tape cassette to stay down, rewind the emergency eject latch wheel in the opposite direction a few turns. Push the latch down a couple of times to make sure this cable actually pulls the roller and disengages from the supply reel. Then put the screw back in and tighten it. Replace the cover, making sure the screws are seated, and tighten the screws. Pop the cassette and replace the cassette cover. Tighten the screws. Replace the front cover and tighten the screws. Demonstration of the emergency tape unloading process for the studio deck will be done with the carriage assembly removed to clearly show the process. Emergency tape removal is done with the power off. Push down on the loading ring and start to turn the loading gear in a clockwise direction. Take up the slack in the tape by pulling it along here, being careful to handle the tape only by the edges. Alternate turning the loading gear and taking up slack in the tape as shown here. At this point, we can lift the tape off and curl it out of the way. The tape also needs to be relieved from the P2 guide. Continue turning the loading gear and taking up the tape slack until the tape is off the drum and is loosely piled in the middle. Now lift up and remove the cassette while holding the door up. We'll continue the demonstration of emergency tape unloading for the studio machine while the carriage is in the unit. Locate the loading motor. Start to wind the loading motor to bring the cassette assembly up. This takes time, so be patient. The cassette will start to come out of the machine here. As it starts to come out of the machine, gently pull it out. The tape is piled up here, and we need to get it out of the machine. Pick up the tape, making sure it is free and clear. Start to pull the tape out while keeping the cassette door up, and make sure that the tape is not catching on the posts. With the cassette out of the deck, rewind the tape into the cassette by manually turning the take-up reel, making sure there are no wrinkles in the tape. You can also take up the tape on the supply reel if necessary. This concludes Lesson 1. Careful cleaning and maintenance of your M2 equipment will ensure long life and high performance. Careful attention to detail is necessary. The techniques required for cleaning some components could be damaging to others. Be sure to read the technical manuals before and during cleaning and maintenance of your M2 equipment, and consult your Panasonic engineer for correct maintenance intervals based on your usage. This tape will assist you in the upper drum replacement on the M2 Studio VTR series. It will cover chip protrusion measurements, head replacement, and general alignment procedures. Although the tape does not replace the service manual, the procedures outlined here will make head replacement much easier. Cleaner roller removal. This is the cleaner roller assembly here. And this is the cleaning shaft with the roller behind it. We need to remove the cleaner roller so we can mount the fixing plate in order to measure the tip protrusion. To disassemble, remove the screws located here and here. Mounting of the fixing plate for the tip protrusion gauge. The fixing plate for the tip protrusion gauge is mounted here and attached with screws. Now the gauge can be attached. Make sure that this part at the bottom is in a straight line, in the same plane. Then insert it down here. Make sure that the base does not touch the lower drum, and make sure the top of this part is even with the top of the upper drum. Now the dial gauge can be attached to the upper drum. In this case, the gauge is improperly mounted and needs to be dropped down. While mounting the gauge, take care that a video head is not in the way. Video head tip protrusion measurement. Turn the thumb screw until you feel contact with the upper drum. Note the measurement on the gauge. In this instance, it's 120 microns. Rotate the drum until the gauge comes into contact with the center of a head and note the measurement again. In this case, it's 150 microns. By subtracting 120 from 150, we get a tip protrusion of 30 microns. This is within the specification of 35 to 15 microns. Removal of the upper drum assembly. This is the upper drum assembly. There are 3 pairs of wires that have to be removed on this side, here, here, and here, and 3 pairs of wires removed from this side here. Use a soldering iron to melt the solder so the wires can be removed. Clean up the connections using the soldering iron to melt and pick up the solder. Now we're ready to disassemble the upper drum assembly. Remove the screws here and here. Lift off the assembly. This is the lower drum. These wires connect to the lower rotary transformer that passes the video signal from the heads back up through the wires into the head amplifier. Do not remove any of these wires. Upper drum reassembly. Before reassembling the upper drum, clean the lower drum. Check for any scoring or other physical damage on the lower drum. Now replace with a new upper drum assembly. Note that it is important to match the color-coded wires, red and yellow, shown here, and blue and yellow, shown here. If the wires aren't matched, the fields will be reversed, causing problems. We can see that in this case the colors are not matched. So we need to rotate the drum 180 degrees so that the colors match. Now install the mounting screws that attach the upper drum assembly. You don't have to rotate the drum in this way to tighten the screws. You can just turn them by hand, whichever method is easier. Be careful not to cross-thread the screws. Once the screws are set and tightened, back off 1/8 of a turn. This will allow lateral movement of the drum while making adjustments. Resolder the wires, being careful to align the same colors together. For instance, the red is connected to the red, the yellow to the yellow, and so forth. Also make sure that stray solder does not accidentally connect different color pads, as this would cause a short. Continue until all the wires are connected. Eccentricity gauge adjustment. Mount the base plate for the eccentricity gauge by first putting in this screw and then this screw. Mount the gauge here. Making sure the tip is located between the top of the upper drum and the first air bearing. Then tighten it down. The specs are set for less than 3 microns of deviation. To do that, turn the knob so that the needle rotates once around the dial. Rotate the meter to 0. Rotate the drum to make sure the dial does not move more than 3 microns. If adjustment is needed, rotate the drum to find a high point. When you find the high point, bring it back around and adjust to less than 3 microns. We can see here that after the adjustment, the eccentricity gauge is less than 3 microns. The next section covers the simplified head replacement adjustments. Please follow the flowchart for adjustment sequence. The first step is the PG shifter adjustment. The video signal comes from TP309 on the W3 board. It is easier to see the video signal here compared to TP13 off the W5 board as stated in the manual. We're going to use TP7 on the W5 board for triggering. That's the head switching pulse located here, and make adjustments on switch 1 and switch 2. Here is switch 2, which is the fine adjustment, and here is switch 1, which is the coarse adjustment. This is a properly adjusted PG shifter waveform. For demonstration purposes, we'll misadjust switch 1, the coarse adjustment. Use switch 1 for coarse adjustment, followed by switch 2 for fine adjustment until you get a properly adjusted waveform as shown. The second step in the simplified head replacement flowchart for the Y signal side of the AU65 is the record shifter adjustment. The adjustment is made in this area VR1. We're going to adjust the unit while it is in the record mode, sending 75% bars to the unit. One test point for triggering is TP7 on the W5 board, and the other is TP309, although the manual calls for TP13 on the W5 board. When we adjust pot number 1, we want to be at least 2.75 H into vertical serration of the picture. This is now a properly adjusted waveform, here and here. If we check the slope, we want to also check for the duty of the record shifter pulse. This is the alternation of the duty here That duty should be very tight within 2 nanoseconds of each other. This waveform is now properly adjusted. The third step in the simplified head replacement flowchart is the AC X value confirmation and adjustment. Usually, after upper drum replacement, the X value doesn't change, but it still needs to be confirmed and adjusted if necessary. If this adjustment needs to be made, insert the alignment tape, VFM 7089 EAG, and go to the field skip portion at 16 minutes into the tape. Connect the oscilloscope's channel 1 to TP301 on W3 and channel 2 to the channel 2 audio out. Loosen this screw and this screw and insert the eccentric driver in this hole. Turn the unit onto play and observe the waveform. This is field 1, 2, and 3. Field 4 is skipped. This is channel 2 audio only. Channel 1 has a notch. Adjust so that these two keyways are aligned. Also check for maximum RF so that it doesn't drop and come up when you change the X value adjustment. The fourth step in the simplified head replacement flowchart is the Y playback RF level adjustment. For channel 2, you're going to be triggering off TP7 on the servo board. That's on the edge, so you can leave the board inside and use the extender board for the W3 board. Connect the channel 1 probe to TP301 on W3. The adjustment pots are 301, which is channel 2, and 303, which is channel 1. The adjustment is for 400 millivolts plus or minus 50 millivolts. This is properly adjusted. But for demonstration purposes, we're going to misadjust 303. This is the effect of misadjustment of channel 1. Now we'll readjust channel 1. Next, we'll adjust 301 to first show misadjustment and then proper adjustment. This is what it should look like. If the RF levels are correct, you won't need to adjust anything. Step 5 in the simplified head replacement flowchart for the Y signal is the Y playback frequency response adjustment. The two pots that we're going to be adjusting are VR315 and VR316 on the W3 board. To make this adjustment, take video out or component Y out, although component Y out is the best to use. Then look at the difference between here and here. Minimize the difference between the two and make it flat like this. You can expand it in order to see it better. You can go from channel 1 to channel 2 by pushing the plus-minus slope button on the oscilloscope. Right now, we're adjusting channel 2. If we want to go to the negative slope, this is the other channel. Adjust for a flat RF envelope and minimize the moire at the 4.5 MHz position. That's also adjusted here and here. The sixth step in the Y signal side is the Y record current adjustment. The adjustments are to VC1 and VC2 for channel 1 and 2 record EQ, and VR3 and VR4 for channel 1 and 2 record current levels on the RAHA PC board. Adjust VC1 and VC2 to achieve a level between the minimum and maximum level as shown. Place the unit in record and find the maximum RF level. Play back the recorded portion and confirm a level of 640 millivolts. Step 7 in the Y signal side is the self-record playback frequency response confirmation. Record a 60% sweep signal. If not available, multiburst can be used. Play back the just recorded portion and confirm a 100% level from 0.5 MHz to 4 MHz. and 95% at 4.5 MHz, as shown. Usually, if record current is adjusted correctly, the record frequency response will also be correct. Step 8 in the Y side is the Y PB1 at RF level confirmation. Observe the waveform at TP301 and confirm that the RF envelope is 400 mV. If not, readjust VR301 and 303 on the W3 PC board. The ninth step in the simplified head replacement flowchart is the Y demodulator balance adjustment. This involves two adjustments in this area of VR318 and VR319 on the W3 board. First, let's adjust VR318. We want to adjust to minimize the moire in this area here and here by adjusting this pot. This is how the waveform looks when it's properly adjusted. Now let's adjust VR319. The waveform shows moire that needs to be adjusted. Adjust it until the moire is minimized as shown by the waveform. This is the component Y output level. Adjust for a Y level of 0.7 volts peak to peak. Check that the sync tip level is 0.3 volts peak to peak. These are the Y adjustment pots for the component output level in this area. The two adjustment pots that we'll use are the VR200 here, which is the Y gain, and the VR201, which is the Y DC level. With the Y component input, be sure to use a T connector and a 75 ohm terminator here before you make your adjustments, or the level will come up. This is step 1 in adjustment for the C signal side in the simplified head replacement flowchart, the CRF level adjustment. We're going to use TP701 on the W3 board and the adjustment pots VR701 and 702. 701 is for channel 2 and 702 is for channel 1. Our first adjustment is for channel 2. Observe the waveform monitor. Now adjust channel 1 and observe the waveform monitor again. This is a properly adjusted waveform. The second step in the simplified head replacement flowchart for the C signal side is the C playback frequency response adjustment. To make this adjustment, take the R-Y or B-Y component out to channel 1 and trigger the scope off TP7 of W5. The adjustment pots for this adjustment are VR712 and 713 on the W3 board. We want to adjust to minimize moire. You can easily see it on the scope like this. Adjust to flatten out the envelope. You can see that it is grossly misadjusted here, and you need to flatten it out. An easier way to see it change the fields is by pressing the plus or minus slope key, as was done for the Y signal. The third step in the C signal side is the C record current level adjustment. The adjustments are to VC3 and VC4 for channel 1 and 2 record EQ, and VR5 and VR6 for channel 1 and 2 record current levels on the RA-HA PC board. Adjust VC3 and VC4 to achieve a level between the minimum and maximum level, as shown here. Place the unit in record and find the maximum RF level. Play back the record portion and confirm a level of 640 millivolts. Step 4 in the C signal side is the C record frequency response. Record a 60% sweep signal. If not available, modulated multiburst can be used. Play back the just recorded portion and confirm a 100% level from 0.25 MHz to 1.5 MHz as shown here. Usually, if the record current is adjusted correctly, the record frequency response will also be correct. Step 5 in the C signal side is the C-RP-AT RF level confirmation. Observe the waveform at TP301 and confirm that the RF envelope is 400 millivolts. If not, readjust VR701 and 702 on the W3 PC board. This is the component PB level output adjustment. This adjustment is made using VR203. For adjustment, play the 75% portion of the alignment tape. By turning VR203 and monitoring the terminated PB out, adjust the level for 4.86 volts. This adjustment is for component PR output level, which is made in this area, using VR205. Adjust the level for 4.86 volts. Adjust the composite YC output timing while watching the waveform monitor using the portion of the alignment tape at 12 to 16 minutes in. The adjustment for the composite YC output timing is made on VR207 and VR208. Be sure you are in the preset position under the front panel when making this adjustment. First, adjust VR207 here. This portion has to be flat. If it's misadjusted, you can see the difference in timing between the A portion and B portion. Right now, the B portion is misadjusted, and the A portion is misadjusted, as you can see here. Adjust so that the line is flat all the way across. This is the last step, the Video 2 Level Out Adjustment. Adjust the video level to 0.714 millivolts peak to peak from blanking to peak white. Make sure that the encoder out adjustment pots on the front drawer are in the center détente position before making the adjustment. The adjustment is made in this area on VR501 and 502. VR501 is the video gain level adjustment. VR502 is the video DC offset level, or the blanking level. When adjusting for Video 2, confirm that the DC level is here. This is the ATX value adjustment for the AU63. On the edge of the W5 servo board are the adjustment pots, the auto preset, and the LED indicators. First, set the switch to the preset position. Note that the RF LED will start to blink. Insert the alignment tape and place the unit into the play mode. Adjust the AX and BX pots clockwise until both fields fully collapse. Now readjust so both fields return to the first maximum position. If you go past that point, the envelopes will collapse upon themselves. Place the unit into the variable 4/32 times playback mode and then observe the waveform. Now it's time to adjust the A and B gain pots. When the gain is misadjusted, you can see fluctuations from one side of the envelope to the other as the A gain pot is turned. Do the same for the B side and adjust for a level envelope. Confirm this procedure by running the tape from forward to reverse and back again. The picture on the monitor and the RF envelope should not tear or break up. If it does tear, readjust the ATX value again, and if that doesn't help, check the P6 post and refer to tape 1. This video is the third in a series on fundamental training for service, maintenance, and operation of the Panasonic M2 line of equipment. This presentation specifically deals with the fundamentals of troubleshooting to assist service personnel in identifying and defining basic system and component problems. Introduction. For the purpose of this troubleshooting presentation, 3 system configurations will be discussed. These configurations are standalone single machine, machine-to-machine, and basic AB roll machine editing configuration. By approaching the topic of troubleshooting in this order, the student can effectively learn to isolate component problems from system and interface-related malfunctions in a building block type format. Section 2. Standalone single machine configuration. First, let's look at the basic internal system functional areas of the standalone machine. The NTSC signal from a camera or other machine source is first sent to the decoder, where it is separated into the Y and C signals. The C signals consist of the R-Y and B-Y components. Next, these signals go to the CTCM section. At this board, the C signal is compressed and both the Y and C signals are then modulated onto the tape. This is accomplished through the record amplifier. The low-level modulated signal is applied to the heads. Actual head switching is done on the head amplifier board. In the playback mode, the signal is sent from the heads to the playback amplifier, where it is amplified before going to the TBC and encoder section. In the TBC and encoder section, the signal is digitized on the encoder board and sent to the TBC board for signal processing. During processing, new sync is generated and dropout compensation occurs. Also, the NTSC signal is rebuilt from the components Y, R-Y, and B-Y. It should be noted that H-series units have super dropout compensators, or SDOCs. The actual SDOC unit consists of one baby board that is added to the TBC board. This enhances the unit's ability to correct dropouts up to one field in duration, either in the Y or C channel. Older units may have this as a modification. Now let's go through this block diagram and identify problems that could occur attributable to each section. If the decoder section is malfunctioning, typical symptoms might be no recording, but playback is still available. The input levels of the recorded signals may be too high, or either the Y or C channel only are operating. In the CTCM section, typical problems might be no color or no wide detail to the picture. The FM modulator should be checked along with the clamp circuit. You may also experience no FM audio, which would also be attributed to the CTCM board. Check the connections, the FM audio signal in, and the FM audio modulator. The record and playback amplifiers should always be checked when there is a playback problem that would typically manifest itself as either no Y and/or C signal. In addition, loss of one field in either the Y and/or C channel should be addressed by first checking the record and playback amplifiers. Other playback problems may also be attributable to the TBC and encoder section. Troubleshoot this by making a tape and playing it back in a known good machine. If there's no problem, then the TBC is suspect, and symptoms such as levels, quantizing errors, missing bits, vertical jitter, and sync malfunction can be studied and isolated at the TBC and encoder boards. By isolating a problem to a specific unit and then identifying which section of the unit is suspect, troubleshooting can be effectively performed even in the most complicated systems, regardless of the number of units. Let's move on now to discussing such systems and their interfaces in common applications. Section 3. Machine-to-machine, or cuts-only applications. A basic machine-to-machine system employs 3 cables. They are the dub cable, a 9-pin RS-422 cable, and an optional reference video cable. The dub cable allows the signal between the machines to be in the component mode. If there's a problem with this signal, the servo not locked caption will appear. First, make sure that the CTCM line switch is in the CTCM or dub position. Next, ensure that the internal-external sync switch is in the correct mode. Check the connections to make sure they're secure. Finally, loss of the signal may be caused by a head clog. The 9-pin RS422 cable is the communications link between the units. The protocol is based on SMPTE and Sony specifications, allowing the M2 machine to emulate either M2 or Sony BVU and BVW units. If communication or control is lost between machines, first check the connectors on this cable. Next, make sure the remote local switch is in the local position for the recorder and remote position for the player. If you push any button and the deck beeps, this switch is incorrectly set in the remote position when there's no remote controller or RS422 cable connected. The optional reference video cable is not a must, but helps lock the internal synchronizers together during pre-roll and cue functions. For proper operation, ensure that the internal-external switch is in the correct position. Now let's look at a more complicated AB roll editing system. Section 4. AB roll editing systems. This block diagram shows a very simple AB roll editing system. RS422 interfaces control the A and B playback machines, in addition to the edit recorder and edit controller. A blackburst generator provides reference video in to each of the 3 units, the switcher, and the edit controller. Video out from each of the players is sent to the switcher. The switcher's video output is sent to the edit recorder. Preview monitors are fed from the Video 3 output of both players and the edit recorder. As you'll notice, all units are directly connected except for the video out monitor loop from the edit recorder, which goes through the waveform monitor, vector scope, and finally the program monitor, which is impedance matched with a 75 ohm terminator. If this loop wasn't terminated, the signal level would be abnormally high. It's important that all loops in any system are terminated properly to avoid reflectance in the system that would manifest itself as AC hum. It's important to eliminate as many loops as possible when configuring your system. In an AB roll system, we must be able to separate system problems from machine problems. There are 3 basic areas to be concerned with. First, editing modes. Then, playback, pre-roll and review, and finally, recording. In the editing mode, the symptoms would include basically that the unit won't make an edit, or that it pre-rolls but no edit occurs. Let's look at some of the probable causes. First, the obvious. Is the record tab on the master tape? Next, check the 9-pin connections. Next, check to see that the editing mode lamp is on correctly. Check that the standard non-standard switch is in the correct position for your editing. Ensure that there is a video input. Check if the reference video is connected. Make sure that the CF switch is in the right position, 2F or 4F. Make sure that the capstan lock is in the right position, auto or locked. Check if there is an out point entered before the in point. Ensure that the timecode is present and continuous, especially if the unit continues to shuttle back and forth. If in the insert mode for editing, ensure that the tape is not blank. Check if there's a break in the control track during pre-roll. Now let's look at some playback problems. Breakup, or if the picture turns green or purple. First, is it a clogged head? Clean the heads. Is the tracking knob off track? Adjust accordingly. Check to see if the tape's damaged, especially at the edge where wrinkles may occur. A break in control track. a low RF indication. Now let's look at some other playback symptoms. Rolling or jitter. Let's look at some probable causes. First, check the reference input and ensure that the internal-external position is correct. If the vertical sync comes down halfway on the screen, turn off the editing mode lamp. For horizontal shift or jitter, check the CF position. For vertical jitter, check the TBC section. Check to see that the ACX position is misadjusted. Check to see if the PG shifter is misadjusted. If the symptom is excessive dropouts or poor AT tracking, first check to see if the heads are worn or dirty. Check to see if you have bad tape. Check to see if the ATX values and the gain are misadjusted. Adjust the dropout compensator. It should be noted that bad AT tracking in its slightest case will be exhibited by noise in just one field. In the worst case, when playing back bars, you may see large vector dots on the vector scope. Now let's look at some systems associated with recording problems. If the symptom is a noisy or a hot screen, the probable cause might be dirty heads or problems with the tape path. Another problem could be a bad tape. Also, check to see if the record current is misadjusted. Check to see if the record amp is misadjusted. Finally, check for an unterminated input. If the symptom is jumping, rolling, or jittery recordings, check to see if there are two video signals connected to an input. Check for misadjustment of the ACX position. Check to see if the record shifter is misadjusted. And ensure that you have a time-based corrected signal at the input. Now let's look at how to operate the M2 menu and recommended settings. Section 5. M2 Menu and Setting Instruction. This guide will assist the user to access the different machine functions and to set up the unit for the best conditions in an editing environment. Please note that although many settings will work in any situation, the use of the drum stop setting is not recommended in a mark machine application. First, let's look at how to access the menu and selection procedures. Make sure the unit is in the stop or reject mode. Lift the front panel and press the System Setup menu button on the B1 PCB. Monitor the Video 3 output. Make sure that the super switch is set to on. Select the desired menu group. The operation instructions list all the groups and available choices. To access the desired group on the main menu, turn the shuttle knob clockwise and the groups will change 1001, 1002, etc. to list your choices. To access the choices on the submenu, hold down the stop button and turn the shuttle knob to see your choices 00, 01, 02, etc. After making your selections, make sure that the set button is depressed or your selections will not be made. Of course, if you only wish to look at what settings the unit is currently using, access the menu as described here, but afterwards, instead of pressing the Set button, press the Menu button to get out of the menu mode. The unit settings will remain as they were. Now let's look at some recommended settings for the editing environment. The settings shown here are the result of research to determine what has worked effectively for M2 editors. You may wish to make alterations based on your particular applications and experience. Please refer to Tape 1 and Tape 2 of the Panasonic M2 training series for specific procedures referenced in this video. The technical manual also contains extensive detailed information for the subjects discussed here. You will also find a full description of all menu options which are available to control machine functions.